All right, section 3.6, we're going to break into a couple different videos. We're going to have one where we kind of give you some basic information about what we're going to be doing, and then in the second video we'll talk about the process of how to do this. So what we're going to look at in section 6 is what we call critical points in extrema. We're going to look at polynomial functions. Okay, so things like x cubed plus 4x squared minus 7x plus 8. And we're going to look at the graphs of those, and we're going to find what we call some critical points, which are points that on the graph where when we draw a tangent line, okay, tangent line again, anytime we have a line that intersects our graph, if you remember from geometry, in exactly one point, so that would be a tangent line there intersecting this point. But that's not the points we're concerned about. The points we're concerned about are when these lines, these tangent lines, are horizontal, okay, or vertical. Because what happens is this horizontal line now intersects that quadratic piece here, and if you think about even if we made it into, you know, a higher order function, at the point where we're changing direction. Okay, and that's what we're looking at. We want to look at those points where we change direction, because this is what we're going to talk about as a minimum value. Okay. We also look at verticals. Okay. And what's happening here is we're not looking at any line that just happens to cross and intersect once, because yes, that's true, those intersect in one place, but there's going to be some curvature going on. Okay, what's going on with the second example is that we're changing from, you know, that if you look at that graph as it's approaching the y-axis, it's slowly getting bigger, and as it gets closer, it's getting bigger a little quicker, and then all of a sudden it changes and slows down. So we change the speed at which we're increasing. Okay, and so we'll look at that, and that's going to be what we'll see in a second here as a point of inflection. Okay, so our three types of critical points we can have is minimum. Okay, we could have a maximum. Now I have on here, yes, quadratic functions, but again, like I said, these could be higher order, and that's still going to be what we're going to talk about as a maximum. Or we get this point of inflection again where we change kind of our speed that we're increasing at. All right, now we can talk about a couple other situations here. We can have what we call absolute, or we can have what we talk about as relative minimums. Okay, now in this function that I have here right now, okay, if it is quadratic, this would be called an absolute minimum, because that's the smallest it'll ever get. Okay. There's no y values less than that y value of 0 in this case. But we can also have what's called a relative, or sometimes it's called a local maximum or minimum. Okay, so for instance, if I kind of go like this and resketch another graph, okay, this point right here, okay, in this region, in this locality, okay, it's a maximum. Okay. It's not an overall maximum, but in that little region there, it is a maximum. Just like this point right down here, in this region is a local or relative minimum. Okay. These are going to be important because these are points where, again, if I draw my tangent line, it's horizontal to it. Okay, so that's why we want to take notice of those points. All right, so a couple things to review here as we go in as well. Odd degree functions. Okay, remember, degree is your largest exponent, okay, your highest power. So odd degree, x to the first, x to the third, x to the fifth. What happens is we have one tail up, one tail down. Okay. When a is positive, a again is your leading coefficient. Or the coefficient of that highest powered term. If it's positive, it's overall increasing. So it looks something like this. We'd start by coming up, change direction a couple times maybe, but at the end we'd overall end up increasing, I'm sorry. So an example, this might be like y equals 3x cubed plus ... When it's negative, you're going to have a situation where we're going to be decreasing over the whole situation. Okay, so I start by decreasing, maybe change direction a couple times. In that situation, y equals negative 4 x to the fifth, on and on and on. Okay. When we have even degree functions, x squared, that's the one I always tell people to think about because you should understand the idea with your quadratics of opening up or opening down, but we get both up or both down when a is positive. So if I have y equals 2x squared, okay, we want to think about it as, oh yeah, that's one that opens up. When y is negative, or your leading coefficient is negative, your a value, so negative 3x to the fourth, that's when we're opening down. So it's good to understand what my graph is going to look like before we even get started. All right, so that's the end of this first piece.